Hi, this is May Week 2, 3rd grade math, and you'll need this piece of paper. We're going to be learning how to find the area of an irregular polygon. And just super quick for review, this is a polygon. A polygon is any simple closed curve that has straight sides. An irregular polygon is a polygon where the sides are not all the same length, and you can see that this one's definitely an irregular polygon. A regular polygon would be a hexagon or a decagon or a square. And while you're getting this paper, you'll also need a ruler and a pencil. We're going to also review a couple things we have learned. If you remember Quat, the farmer who had the tiny field, and how back in thousands of years ago, ancient rulers had to figure out how to measure area so that they could charge people the correct amount of tax money. Otherwise, a farmer with a really tiny field might feel like they couldn't feed their kids if they had to pay too much tax money, and then they'd all rise up and get rid of the ruler. However, the ruler did want to tax everybody so that he could provide bridges and roads, he or she. And that also benefited small farmers like Quat, because then that farmer could transfer their goods and get better prices for them in the cities. They could use the roads and bridges to get to the bigger markets. So it was a win-win. And you remember when we were figuring out how did the ruler figure out how much to charge Quat? It was all about the area of Quat's field. And they figured out that area does not mean you have to put rope and measure how many square feet Quat's field is with bits of rope marking off every square foot. Instead, you just need one piece of rope to show the length and the other piece of rope to show the width. And then you just imagine the squares. So it's length times width. And that's how they figured out area. Well, that was for a rectangle. Quat's field was a rectangle. Last week, we learned how to find area of a triangle. In triangles, you have to imagine that the triangle is inside of a rectangle, and then you take half of that area. So a triangle is half length times width. So we're going to think about how to find the area of an irregular polygon like this, and the reason why is not all fields are rectangles. Some fields look like this. This could be a field that maybe has a mountain sticking into part of it, a really steep slope right here. Or this could be a road that cuts across. Or here you could have a river making these strange lines. And of course you can still farm that land, but it isn't going to be a rectangle, is it? Because of nature. So some fields look like this, and we can chop this shape up into something. Can any of you see what it would be? It would be triangles. All right, go ahead and get your ruler out. I'm thinking we could continue this line across here to there, and we should be able to get a triangle out of that. Go ahead and do that. And now we can see that this irregular polygon is actually got two triangles in it, and we just need to find the area of each of those. So if you remember, area of a triangle is half of length times width. Let's go ahead and assume that this is the base of this little top triangle. The base is whatever side the triangle is kind of sitting on. And to me, that looks most like the base. So let's measure the length of that base. Put your ruler and count from 0, 0, 1, 2, 3, 4. I got 4. And go ahead and write it for that length, from there to there, the base of the triangle. Now we need the height of the triangle, and if you guys remember, we talked about this last week. The height is not necessarily the sides. It's from the base to the vertex, straight up. So we're going to go straight up, starting from 0, from the base to the vertex. And 0, 1, 2, 3, 4. It's 4 again. Okay, that's very important to remember, that the height or altitude of a triangle is from the base to the vertex of the triangle. Now, if you imagine that this triangle was inside a rectangle, that rectangle would probably look something like this. And the height of that rectangle is going to be 4 because you just measured it in the middle. It's 4 over here and it's 4 over here, okay? And the length is also 4 because the rectangle has the length of the base of the triangle, okay? So imagine that the height of the rectangle is 4. It's just that you measured it kind of in the middle. It's still 4. So the area of this rectangle would be length times width, which is 4 times 4. And let's skip count our 4s. 4, 8, 12, 16. But the triangle is half of that. Not 16. The triangle is half of 16. So we're going to skip count 2s till we get to 16 and see how many 2s we have. 2, 4, 6, 8, 10, 12, 14, 16. We have 8 2s, so half of 16 is 8. So somewhere in the triangle, write 8. And it's 8 square inches. Now let's look at this triangle. The base of this triangle is kind of difficult to find. It's whichever side the triangle could be sitting on. And obviously this triangle is being naughty and tilting its chair, like you do sometimes. And so this triangle's base is very tilted. Let's go ahead and measure that base. Starting from 0. Put your ruler. 0, 1, 2, 3, 4, 5, 6, 7. So this is 7. Now we need the altitude or height of that triangle. And again, we're going to go from the base to the vertex. And since this triangle is tilted, the vertex is kind of sideways a little bit, but that is still the tallest point of this triangle. And you're going to measure from 0, 0, 1, 2, 3, 4, 5, 6. Okay. So now we have our length and our width of an imaginary rectangle that this triangle is sitting inside of. And the imaginary rectangle would be something like this. You don't have to draw it, I'm just showing you. Okay? Something like that. You've got a rectangle that this triangle would fit in half inside of, and of course this triangle is half of the area of that rectangle. So for the area of that rectangle, we've got the length of 7 and the height or width of 6. So let's skip count 7 6s. 6, 12, 18, 24, 30, 36, 42. 7 6s is 42. But we don't need that. We need half of that. So we're going to do a real quick long division. 42 divided by 2. Looking at that, we can tell that 2 is the divisor and 42 is the dividend. The divisor 2 is going to fit into the dividend definitely a 10 of times. What is a 10 of 2's? Well, you just add a 0, right? 10 times 2 is 20. In fact, who thinks 20 would fit more than once into this dividend? I hope you all said it will. It'll fit more than once, won't it? It's going to fit twice, probably. Just a good guess. So let's see what that would make. Take that 20, which is a 10 of twos, make it twice. 2 times 0 is 0. 2 times 2 is 4. So we get 40, which is actually really close to this dividend up here. It does fit if you do it 2 tens of times. So go up here. In your quotient, put a 2 in the tens. And then you need to write what 2 tens of 2 is. It's 40. And subtract that from your dividend. Starting with units, 2 take away 0 is 2. 4 take away 4 is nothing. So all you have left is 2. Now look at your divisor. How many times will your divisor fit into what's left? I hope you all know this. It's once, right? How many times will my marker fit into my marker? Once. How many times does 2 fit into 2? Once. So go ahead and put 1 up here in the units, and then write what it is. One group of 2 is 2. And subtract. And of course you get 0, which is good. Okay, so half of 42 is 21. Write that in this bottom triangle somewhere. 21. Now we can see that we've got 21 for this part of the irregular polygon and 8 for the top part of the irregular polygon. 21 plus 8. I'm not going to do an algorithm for that. We can just do it with our fingers. Hopefully some of you know it, but for those of you that don't, we'll do 21, 22, 23, 24, 25, 26, 27, 28, 29. 21 plus 8 is 29. So the total area of this irregular polygon is 29. So somewhere on your sheet, you can write area is 29. And do you remember our unit of measurement? We were measuring in inches. So we're going to write IN dot. That's an abbreviation for inches. And then you do need to write squared. You need to put your little exponent right there and make sure you write 29 squared, because we measure area in square inches or square feet or square miles. It's always in something squared. Okay, I hope you guys enjoyed that. It's pretty fun figuring out how to find the area of just about any shape. Could be even a circle. In fact, that's how they figured out pi was just dividing a circle into these very, very, very skinny triangles, and almost like the spokes of a bicycle, but even a lot skinnier. And then they got pi from figuring out the ratio of the size of the triangle to the diameter of the circle. I would like to tell you a story, because that seems to be a tradition that we're starting. And it's not the 1st of April, but it's an April Fool's story. It's a story about a school long, long ago where a person who's very, very old now went, and that's me, yours truly, Miss Cammie. I went to school in England. We had school uniform, and I loved my school uniform because it meant that we all kind of looked the same, and so nobody could judge me on my clothes because my clothes were all hand-me-downs from my older brother. And if people had seen them, I don't know if I would have had any friends. At the schools in England, there's a formality that you do. It's when a teacher walks in the classroom, everybody stands up. And then the teacher says, "Good morning, class." And then you all say, "Good morning, Miss So-and-so." And then you can sit down, okay? So now I want you to picture me and about 29 other girls wearing our school uniform, blue sweater with 2 yellow stripes, blue tie with yellow stripes going diagonally, a blue skirt and a little white shirt. And it was the 1st of April, and we wanted to play an April Fool's trick on a teacher that we kind of thought was kind of weird, and his name was Mr. Wilson, the music teacher. And we all whispered, okay, what are we going to do? What are we going to do? I know. Let's unzip our skirts. And that way, when Mr. Wilson walks in and says, "Good morning, class," all our skirts will fall down because we're standing up. Yeah, let's do that. Yeah, that's great. Okay, so we're all sitting there waiting for him, and we all unzipped our skirts. Okay, Mr. Wilson walks up the steps. Mr. Wilson opens the door, and everybody stands up. And everybody except me had chickened out. They had all quietly done their zippers back up. They were like, nah, I'm not going to do this. Everybody except me. So it turns out that April Fool's joke was kind of more on me, doesn't it? All right, I hope you guys have a great week.